Let's look at question number 2. So we've got a volatile hydrocarbon. Volatile means it's got a low boiling point. Hydrocarbon means it contains hydrogen and carbon only. And we seem to have been given the mass of it, the temperature of the system, of the room, the pressure, and the volume. So it's pointing towards PV equals nRT, especially since we've been given R here as well. So the only equation with R in it is PV equals nRT. So that's clearly what we've got to use. Remember, temperature is going to be in Kelvin, which is correct. If it weren't in Kelvin, if it were in degrees C, to convert degrees C into Kelvin, you add 273, but it's already in Kelvin. Pressure has got to be in pascals. It's in kilopascals, so to convert a large unit like a kilopascal into a smaller unit like a pascal, you multiply by 1,000, so that's 102,000 pascals. Centimetre cubed is actually going to be in meters cubed, so to convert centimetres cubed into the next unit up, which is decimetre cubed, you divide by 1,000, and to convert decimetre cubed up into meters cubed, you divide by 1,000 again. So it's actually going to be divided by 1,000 divided by 1,000 to get into meters cubed. Let's have a look at our equation then. PV equals nRT. P is in pascals, 102 kilopascals, 102,000 pascals, so we've converted that. Volume is in meters cubed, so as we said, 72 centimetre cubed, divide by 1,000 to get into decimetre cubed, divide by 1,000 again to get it into meters cubed. Temperature is already in Kelvin, so let's put these numbers in then. Pressure 102,000, V 0.00072 meters cubed. N is the number of moles, which I think we've got to find out. 8.31 is the gas constant, R, and temperature is temperature in Kelvin 373. So if we multiply these two out, always good to multiply out the numbers first on a calculator so you don't end up pressing the wrong buttons. 102,000 multiplied by 0.00072 is 7.344. So do that section first and multiply these two numbers, 8.31 and 373 out, and you get 2738.6. Now n is 7.344 divided by 2738.6, and it comes out as 0.00268 moles. I've now got the number of moles. What else do I know about x? I know the number of grams, or at least I can do, 194 milligrams. To convert a smaller unit into a larger unit like a gram, because it needs to be in grams, divide by 1,000, 0.194 grams. So now what have I got? I've got moles, I've got mass in grams. I can work out the MR because moles is mass in grams divided by MR. So 0.00268, which is the number of moles, is 0.194 grams divided by MR. Rearrange the equation so that MR equals 0.194 divided by 0.00262, and it comes out as 72.4. Let's have a look at how many significant figures. Most of these seem to be to three significant figures: 194, 372, 102,000 to three significant figures. 8.31 to three significant figures. So we'll put it to three significant figures because most of the others seem to be to three significant figures. 72.4 to three significant figures. Analysis of a different hydrocarbon Y shows that it contains 83.7% mass of carbon. If it's a hydrocarbon, it only contains hydrogen and carbon, so there's 83.7% of carbon. The remainder must be hydrogen. So if you do 100 take away 83.7, you'll come out with 16.3% is hydrogen. Let's have a look at the solution then now. So we've got 16.3% is hydrogen, 83.7% is carbon. You divide by the atomic mass of each of them. The mass of carbon is 12, the mass of hydrogen is 1. So if you divide each of those, 83.7 divided by 12, 6.975, and this one turns out as 16.3. Not a great ratio, that. So you divide by the smallest, 6.975, 16.3, you divide both of them by the smallest number, so that equals 1. 16.3 divided by 6.975 equals 2.33. So the ratio is 1 to 2.33. Then you multiply by a number you're going to have to spot the number that you need to multiply by to get this fraction into a whole number. 2.33, if you multiply by 3, that equals 7. and this one equals 3. So multiply both of them by 3 and it ends up as a ratio of 3 to 7. So its simplest formula, its empirical formula, is C3H7. Now it needs us to work out, after the empirical formula, the molecular formula. So the molecular formula is its true formula. So we get this from the MR. So we look at the MR. If we add up C3H7, a carbon has got a mass of 12, so that's 36. A hydrogen has got a mass of 1, so that's 7. 36 add 7 is 43. That seems to be half 86. So the true formula is going to be double this, C6H14. You can check out his MR then equals 86 if you wish.